Here we've got a mixed area and volume with trigonometry. Not a huge amount of area and volume, but anyway, we've got the bubbles of a cable car system built in the French city to connect the city centre to Bastille, a former fortress overlooking the city. Each cable car is in the shape of a sphere with a radius of 2. And they would like you to find the volume of one of the cable cars. So nothing too tricky there. We just need the volume of a sphere formula, which is 4/3 pi r cubed, and it's in your tables and formula booklet. Pop in 2 for your radius, and into your calculator gives you 33.5. They wanted to the nearest meter cubed, giving me 34 meters cubed. Nothing too tricky, just to get the brain going. Next up, the diagram shows the journey that the cable cars take from the city centre to Bastille. They travel a horizontal distance of 700 metres and at an angle of elevation of 20.8. As soon as we see right-angled triangles, you want to start thinking about sine, cos, tan, or Pythagoras theorem. Using trigonometry, find h, the vertical height, that the cable cars climb travelling from C to B, and give your answer correct to the nearest metre. Personally, when I have a h, I like to change it to an x, and this is the reason why. I like to label my sides. H the hypotenuse, O the opposite, and A the adjacent. And if I'm stuck with two h's, I can get confused sometimes. I like to go H equals, A equals, O equals. And if I had 3 imaginary boxes here, filling them in, there is nothing next to H, so I leave it empty. A is 700 and O is X. I've got 2 pieces of information, and when I have 2 pieces of information, it'll be sine, cos, or tan. In this case, it'll be tan. If you learn a rhyme perhaps to help you, silly old Harry, I don't have H, so it can't be that. Caught a herring, I don't have H, so it can't be that. Trolling off America, therefore it must be tan. You want to do tan of 20.8 equals X over 700. We're trying to solve for X. You want letters on one side, your numbers to the other. Therefore, this number needs to travel up over the equal sign. If it's divide on this side, over here, it is times. So tan 20.8 times 700, that will give me an answer of 265.9. Rounding that to the nearest meter will give me 266 meters. Sorry. My phone chain is in the way there. So 266 meters. Find the actual distance that the cable cars travel from C to B. So we're now looking from here to here. You have all of the information that you need to use Pythagoras theorem this time, because we just found that that's 266. We know that the base is 700, and we're solving for X, because they've asked you to find from C to B. Therefore, you have to label it X. H, O, A. H equals X, A equals 700, and O equals 266. I have all 1, 2, 3 pieces of information now, and therefore I can use Pythagoras theorem. What's very important with Pythagoras theorem is whatever is next to H goes in here for C. So that's x squared equals 700 squared plus 266 squared. As a reminder, these are interchangeable, as in you can have 266 plus 700, but this here, whatever is next to h, it's not always x, goes in here. That's x squared equals, when you put this into the calculator, you'll get 560,756. You don't want x squared, you just want x. So magically, the x, when it changes over the equal sign, turns into a square root. So you square root the 560,756 and into your calculator. They would like this to 1 decimal place. That will give you 748.8 meters. So the next part, the cable cars take 3.5 minutes to travel from C to B. Find the average speed of the cable cars in meters per second, correct to 1 decimal place. We need our distance speed time. They've asked you for the speed, therefore your formula will be distance over time. The distance that this is traveling is 748.8 meters. Over the time, here's what's important. Don't forget they've asked for this in seconds. And you have minutes. Therefore, you need to convert minutes into seconds by timesing them by 60. So 3.5 minutes by 60 is 210 seconds. So the distance over the seconds, 210, will give us 3.56 meters per second. Pop back up, check that we've got the right value. Says to 1 decimal place, so the 6 will push the 5 up to a 6. Therefore, the answer is 3.6 meters per second.